Have you ever experienced a day where the hours flew by in the blink of an eye? When has time seemed to pass quickly for us? What about the Earth as a whole? Have you given any thought to the rapid speed of time over the past decade, during which the passage of 4 distinct seasons has become a blur to us? We all want answers to these questions. Fortunately, scientists are uncovering some fascinating clues to why time can seem to speed up at certain points for us. The standard day length is 24 hours, which equals 86,400 seconds. But the day's length decreases daily with the increasing speed of Earth's rotation. Scientists at the National Physical Laboratory in England have recorded that June 29th was shorter by milliseconds than the average length, and recorded another shortened day on July 26th. Leonid Zotov, who works for Lomonosov Moscow State University, stated that the Earth started accelerating in 2016 and has recently published an analysis on what might be causing the changes in Earth's cycle. The Earth is spinning faster this year compared to 2021 and 2020. Scientists suppose that tides could have initiated the change in Earth's rotation. Now, the question arises, what are tides and how do they affect Earth? Some scientists say that the tides on Earth result from the gravitational pull of other bodies on our Earth. The other bodies are either the Sun or the Moon. The Moon has the most effect on the tides. As the Earth rotates, different bodies will have different locations to both the Sun and the Moon. The body directly facing the Moon will have the highest effect on it and likely form a tide. The Moon can raise tides on the Earth because the Earth rotates faster than the Moon. The planet Earth forces a tide to go ahead of the Moon. And it is also because the Moon and Earth are closer to each other and have a gravitational pull against one another. As we were saying before, many scientists believe that climate change can be one of the biggest and primary reasons for the change in Earth's rotation. Ozone is the protective layer covering the Earth, which saves the Earth from harmful ultraviolet rays and also absorbs infrared rays produced by the Earth. Humans are destroying the ozone layer with the increased production of carbon dioxide gas and CFCs, letting harmful sun rays reach Earth directly. The ultraviolet rays are changing our Earth's climate. The Earth's temperature is increasing, which is not just hurting the health of human beings, but also affecting the Earth's rotation time, which means the ultraviolet rays are altering nature. The increase in Earth's temperature results in melting the ice glaciers, which can change the Earth's rotation time. Imagine an ice cap melted because of scorching heat, and the water flow is high, which increases Earth's rotation speed, because there are high chances of the speed of water flow affecting the core of the Earth. Another big reason for the change in Earth's rotation is suspected to be a seismic activity, which means earthquakes. When the rock near Earth's fault lines change their position and slip against one another, an earthquake hits the Earth. Because of the destruction an earthquake causes on the Earth, sometimes many buildings break down and their mass moves toward the center or core of the Earth, which can result in a change in the Earth's rotation. Ocean circulation can also be a reason for changes in Earth's rotation. In November 2009, an event occurred in the Southern Ocean that made the Earth spin, resulting in the shortening of half of the day by 0.1 milliseconds each for a whole month. And the mighty Antarctic circumpolar current was the reason behind it. A team of NASA and many European scientists observed that it slowed unexpectedly on November 8, 2009, to quicken up 2 weeks later. This event was so sudden and mysterious that Stephen Marcus said, "This is the first time we have seen a rapid change in the oceans that affects the Earth's rotation." Marcus explained, "The Earth speeding up is just like a skater pulling her arms in. When the skater does this, she spins faster because the laws of physics dictate that her body must conserve angular momentum." He further said, When the skater sticks out her arms, they move pretty fast because there's a big circle. When she pulls her arms in, the circle is smaller, so to have the same angular momentum, she has to speed up. It is the same with the Earth. The thing is, with the ocean, the effect is much weaker since the ocean flows slower than the atmosphere, Marcus said. But in November 2009, he said, a slowdown in the Antarctic circumpolar current seemed to be a lot stronger than usual, and that's probably what made it large enough to be detected in Earth's spin data. We have talked about some of the crucial things that affect our environment. Now, let's talk about some things you can do that can make a lot of positive difference on Earth. According to Zotov, as rotation is not changing daily, but rather from time to time, the universal wait time is measured on Earth may have to change. The universal way of measuring time is by taking the average speed of Earth's rotation. It is the time from one solar noon to the other. Some professionals have recommended presenting a negative leap second, which means removing a second from our regular clock. When you're having a great time exploring with us, time flies by quickly again. If you enjoyed watching and want to explore more like this with me again, don't forget to hit that subscribe button and turn on the notifications for our channel before you go. Thank you so much for watching.